Hi, Assalamualaikum. My name is Muhammad Faiz bin Muhammad Tarmizi. My metric number is 19DRA20F1035. Today as the presentation, I will cover for the project background. While early pedal power motor scooter could technically claim to be original hybrid vehicle, the first hybrid car as we know, it appeared around 1900. The myths developed by Ferdinand Porsche used hub-mounted electric motor in each wheel, which were powered by batteries and a small petroleum engine generator. Hybrid combine at least one electric motor with a gasoline engine to move the car, and the system recapture energy via regenerative braking. Sometimes the electric motor does all the work, sometimes the gas engine, and sometimes they work together. The result is less gasoline burn and therefore better fuel economy. Adding electric power can even boost performance in certain instances. So there is a diagram for the system. First one is internal combustion engine, which is ICE, electrical vehicle EV, and hybrid. There are four types of hybrid system. The first one is a mild hybrid system. Typically isn't going to propel the vehicle on electrical power alone. Instead, the system is used to give a small boost to the vehicle gasoline engine, typically upon acceleration. Second, full hybrid system. Full hybrid system also come with both gasoline engine and electrical component. However, the electrical component in a full hybrid vehicle is capable of handling far more of the workload. Third, plug-in hybrid. The car hybrid system that we have discussed charge the battery solely through internal means. The main difference with plug-in hybrid is that this vehicle can charge the battery via external charger as well as internal. The last one is extended hybrid. Technically don't qualify as hybrid. There are some that come equipped with a small gasoline engine to be provide a cushion when needed. When an electrical vehicle run out of power, the vehicle will need to be use the gasoline engine. That's all from me. Thank you.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Fikri Izwan bin Abu Samah and I will continue the presentation. I will present to you about objective and impact of our project. First, I will tell you about our objective. We have three main objectives in our project. First is to study mild hybrid circuit system. And the second objective is to design my hybrid system. And the third objective of our project is to develop my hybrid system in our car. Next, I will tell you about the impact of our project. We have two main impact, which is first is high torque. So the torque of electric motor will support torque internal combustion engine, which is ICE, at low RPM to match the value of max torque ICE or nearby. So there we show a graph about data about torque electric motor and torque combustion engine. Next impacts, the second impact is quality electric motor. So the electric motor used is very durable and strong, and it can be used every day, which is the rated power of our electric motor is for 4,500 watt, which is it can be high until 9,600 watt. And then a rated voltage of our electric motor is 72 voltage. And next, the rated torque of the electric motor is 13 Newton meter, and it can be maxed to 45 until 55 Newton meter. So the electric motor that we use is very durable and strong. So it heat resistant. It can be used heavy duty. So that's all from I. Thank you.
This is the track we use for the test. This is the result. We had tried three different tests on this project. For the first try, we used only electric motor to run on the track. For the second test, we only use petrol engine to run on the track. And for the last test, which is third try, we use petrol engine supported by electric motor. For the first try, only use electric motor. For the first item, we only got time 1 minute 10 seconds, and second item we got 57 seconds, and third time we got 56 seconds, and the average is 59 seconds. Average time on every 100 meter we got 8.43 seconds. For the average speed, for the first item we got 36 km per hour, and second item we got 44.21 km per hour, and for the third item we got 45 km per hour. For the second test, which is we use petrol engine, only petrol engine to run the car. For the first item we got 1 minute 7 seconds, and second item we got 59 seconds. For the third item we got 55 seconds. For the average time is 60.3 seconds. Average time on every 100 meter we got 8.61 seconds. As we can see, the average time on every 100 meter on electric motor much better than petrol engine because of the instant torque on the electric motor itself. Compared to petrol engine, the time a bit late because of the torque need a certain RPM to get a higher torque. Average speed on this petrol engine test, we got first item we got 37.61 km per hour. For the second item we got 42.71 km per hour. For the third item we got 45.02 km per hour. The comparison of average speed on these two tests, we got petrol engine is higher on first item and third item because of the petrol engine is quite strong on the high RPM, so it can be delivered to the car. For the second test, the petrol engine a bit low because of the traffic on this track. This is the result on the last test, which is a petrol engine supported by electric motor. For the first item we got 59 seconds, and second item we got 55 seconds. For the third item we got 50 seconds. For the average time we got 54.67 seconds. Average time on every 100 meter we got 7.813 seconds, which is better than before these two tests. For the average speed on this test we got for the first item we got 42.7 km per hour. For the second item we got 45.8 km per hour, and for the third item we got 50.4 km per hour. This is a better result because of the electric motor supported on the early RPM, and for the high RPM supported by engine petrol for the deliver to the car. Assalamualaikum and hi, I'm Azri Adli bin Zazuli. Matrix number 19DR820F1033 will explain about the component or part that we use on this project. Firstly is the electric motor. The motor that we use is a QS138 brushless DC motor. The spec is a 72 volt 3000 watt. We choose the sprocket type to connect the motor to the powertrain. Secondly is the controller. We use Votol EM150 sine wave controller to match with the electric motor. This controller also able to run voltage in 48 to 72 volt. This controller has a heatsink on the back for easy heat removal during operation. So we put the controller in high and open place for the wind to pass through to facilitate the heat release process. The next one is a battery. We use a car battery which is Yokobat NS60 to generate power for the electric motor. We put 6 batteries connected in series to get 72 volt we want. Next is a pedal. The way we combine the petrol engine with the electric motor is by connecting the electric pedal on the throttle cable side. We also make both pedal and cables adjustable. By turning this screw to slow down or speed up, the pedal is pressed. This is the demonstration. These 2 tiny screws is for adjusting the petrol cable. The other component that we do is a kill switch for the battery, main switch for the electric motor, and reverse and forward. This is our first try for the forward mode. This is for reverse mode. This is our first try on the road and try some speed and sprint. All these tests only use electric motor to move the car.
The conclusion, we managed to achieve our targeted objective for this project. The electric motor strong enough to work alone, but with combination of petrol engine, the result is more power will produce upward acceleration. The recommendation that we conclude for a better result are to use clutch system for decouple and couple with automatic on or off. Another recommendation is to use torque converter same as in scooter for not interrupted petrol engine and electric motor when both running simultaneously. That's all for us. Thank you.